Solve the following LPP using simplex method for optimal solution. The objective function is maximize z is equal to 6x1 plus 8x2. Subject to constraints 5x1 plus 10x2 less than or equal to 60, 4x1 plus 4x2 less than or equal to 40, x1 and x2 greater than or equal to 0. So this is the LPP problem which we are going to solve using simplex method. Before we start the problem, we need to convert the canonical form of constraints to standard form. Here there are two constraints are there. The first constraint is 5x1 plus 10x2 less than or equal to 60. To convert canonical form to standard form, since the inequality is less than or equal to 60, we need to add slack variable. Now S1 is a slack variable. Now the standard form is 5x1 plus 10x2 plus S1 is equal to 60. For the second constraint, 4x1 plus 4x2 plus S2 is equal to 60, where S1 and S2 are called slack variables. By adding slack variables, we have converted canonical form to standard form. Now the objective function is maximize z is equal to 6x1 plus 8x2 plus 0s1 plus 0s2. The slack variables have the coefficient of 0 in the objective function. This is important to note that the slack variables have coefficient of 0 in the objective function. Now we'll start the simplex problem. This is called initial table, simplex table, where you can see CB, coefficient of basic variables, basic variable, and the variables what we have in the constraints. Okay, now the basic variables in the simplex problem is S1 and S2. So let us take the maximization objective function z is equal to 6x1 plus 8x2 plus 0s1 plus 0s2. Now these values need to be taken into Cj. Cj is a coefficient in the objective function. So x1 has 6, x2 has 8, S1 has 0 coefficient and S2 has 0 coefficient. So Cj are coefficients from the objective function. Now Cb is coefficient of basic variables where we have 0 and 0. If you see, S1 is having 0 coefficient, S2 is having 0 coefficient. The same values are taken in the matrix. Now next we will take about constraints. We have two constraints, 5x1 plus 10x2 plus S1 is equal to 60, 4x1 plus 4x2 plus S2 is equal to 40. Now the values from here constraints are substituted here. The coefficients in the constraints are placed here. 5, 10, 1 because S1 is 1, S2 is 0 and the solution value is 60. So from the first constraints the values are substituted here. Next, second constraint 4, S1 is 0 and S2 is 1, solution is 40. So from the subjective constraints I have taken the coefficients 5, 10, 1, 0, 60, 4, 4, 0, 1 and 40. Next we need to calculate Zj value. We calculate Zj value in the following way. For example, for this value, Zj value, we take 0 into 5 plus 0 into 4. The value will be 0. In the same way, second one, 0 into 10 plus 0 into 4. We get 0. In the same way, we need to calculate Zj value for all other variables. So we have in the initial simplex matrix, we have Zj value as all zeros. Next, we will calculate Cj minus Zj value for each column variable. It is 6. So Cj is 6, Zj is 0. So 6 minus 0 is 6. 8 minus 0 is 8. 0 minus 0. Next is 0 minus 0. So we have calculated Cj minus Zj value for all the variables. In this case, Cj minus Zj values are 6, 8, 0 and 0. So there are two values, 6 and 8, which is not less than or equal to 0. So select the highest non-negative value as entering variables. Now, since we have confirmed that the solution is not optimal, so we need to move with iteration of simplex problem. For moving for the next table, we need to identify which variable will enter into the solution. To do that one, we need to identify the highest non-negative value as entering variable. In this case, 8 is the highest non-negative value which is entering into simplex matrix. Now this is x2. When you say 8 is correspond to x2 variable. So x2 variable will enter into basic variables. Right. So this column is called key column. And key column has 10 and 4 values. Now once we say x2 will enter into simplex table for the next table, now one variable, basic variable, either s1 or s2 need to leave the matrix. So to find that one, we will calculate ratios. The ratio is calculated very simply. The method is take the solution values 60 and 40. From the key column, divide the solution values, that is 60 by 10 is 6. 40 divided by 4 is 10. So the ratios are 6 and 10. Basing on this, we will identify what is a key row. The key row is the least non-positive value. The least non-negative value should be considered as the key row. So this is the key row which will be leaving the matrix, and x2 will substitute in place of s1. So this is a key row which will be leaving. How to identify key row is we need to take the least non-negative value. When you're talking about entering values, Cj minus Zj, we have taken the highest positive value. But here we must take the least positive value need to be taken. Important condition here is if we have any negative value, we must not consider them in the key row values. Now we have identified the key row. The least non-negative value is selected as leaving variable in ratios. Right. Now this table is called iteration 1 because from the initial simplex table we have come to the next table. Now in this table what happens, S1 is leaving and x2 is coming in its place. Now in the iteration 1 table, we will be having basic variables as x2 and s2. Now x2 has entered. To find its values, coefficient values, we need to use the formula old value divided by key element. What is the key element? If you see this table, the row and column are intersecting. The place this is 10 is called as key element, right? And this key element value need to be taken. To find the variables for x2, divide all the values by 10. Means 5 by 10 should be taken, 10 by 10, 1 by 10 and 0 by 10 will become the new values for x2 variable. See, if I divide 5 by 10, it becomes 1 by 2. If I divide 10 by 10, it becomes 1 by 10, and 0 divided by 10, it is 0. So x2 has entered in place of s1. So this is called key row. From key row values, we will find the new values for x1. To do this one, identify the key element. 10 is called key element. Divide all the values in the row by 10. Now we are going to get 5 by 10, 1 by 10, 10 by 10, 1 by 10, 0 by 10 and 60 by 10 is 6. So these are the new values for x2. How many times we have to do the iteration till we get optimality? We must follow the same rule. The leaving variables are old values. Divide the old values by the key element. What is key element here? The intersection of key column and key row. This is key column and this is key row. This point is called as key element. Divide all the values by the key element. Next, now we need to find the values for s2 variable. To do that one, we must use this formula. New value for s2 is old value minus key column value into key row value divided by key element. This formula need to be remembered to identify the new values for s2. Okay, to do this one, I am showing example wise. Right, let us start. This is the old value. 4 is the old value. Now we need to find a new value for this s2. To do this one, the formula we are using is 4. Old value is 4 minus, for this value in row, what is corresponding value? It is 5. Right? And for column, what is the value? 4. This is 4. Divided by key element. What is key element? 10. Now what value we will get if we solve this equation? We get 2. So once again I repeat. In the new iteration table, I want to find the value. To do this one, we must take always the old value. So what is the old value? 4 minus 5 into 4. 5 is called as corresponding key row value into corresponding key column value is 4 divided by key element. Key element is 10. So if we solve this equation, we get 2. Now 2 need to be substituted as a new value for s2. So this is how we need to find all other values for s2. In this case, if you see, I need to find in this place new value. So 4 is a old value minus what is corresponding row value? 10 into its own value is 4 divided by key element 10, so we get 0. So 0 need to be substituted. In the same way, in this case, old value is 0 minus its corresponding row value is 1 into 4 divided by 10. It is equal to minus 4 by 10, which is nothing but minus 2 by 5. Keep the value in here. In the same way, we need to find all other values for the S2 row. The simplex problem will be done in this way, iteration till we get optimality. So you must use the same formula for finding. There are other formulas are also there, but this will be very simple to understand. Now I have found the new values x1, x2 values and s2 values, right? Now find zj value with the formula which we have used. How we are going to find zj value? Multiply 8 into 1 by 4 plus 0 into 2. So if we add this, then we are going to get 4. 8 into 1 plus 0 into 0 is equal to 8. In this way, we are going to get zj values. Now cj minus zj. 6 minus 4 is equal to 2. 0. 8 minus 8. 0 minus 4 by 5. It is minus 4 by 5. 0 minus 0. Now we are checking whether the solution is optimal or not. What is the condition? Cj minus zj should be less than or equal to 0. But here we can see 2 is positive, which is not less than or equal to 0. Now 2 is called as entering variable. X1 is entering variable, and this column is called as key column. This is key column. Now we are going to find ratios. How we find ratios? Divide the solution by key column. 6 divided by 1 by 2, it is 12. 16 divided by 2, it will be 8. So in this way we found ratio. Now the minimum non-negative value should be selected as leaving variable. So 8 is the leaving variable. Now 8 is corresponds to S2. Now S2 will be leaving and X1 is going to come in its place. So S2 is leaving and X1 is going to come. So this is an old table, iteration 1 table. Now this is iteration 2 table which we have here. Now in place of S2 I have X1. X2 will be there as it is. I already said how to find these values. Divide all the values, old values, with the key column, key element. 2 is key element. So divide all the values with 2. 2 divided by 2, 0 divided by 2, minus 2 by 5 divided by 2, 1 by 2 and 16 by 2. So we get these values. Now we need to find x2 values. When you want to find x2 value, you must use old value minus key column value into key row value divided by key element. I already explained you how to do this in the video. So old value is 1 by 2 minus 1 by 2 into 2 divided by 2. If we use this formula, we are going to get these values. And if you see, 8 and 6 are coefficient of these variables. What is x2 way coefficient here? 8. What is x1 coefficient? 6. So these values are here automatically. Now so I have found the new entered values, x1 value, and existing value x2 also I have shown. The formula to get these values are old value minus key column. This is key column into key row values. Corresponding values need to be taken. Divide by its key element. Now find Zj value. How we find Zj value? 8 into 0 plus 6 into 1. We got 6. In the same way, we must find all other values. Now I got Cj minus Zj. 0, 0 minus 2 by 5 minus 1. Now to check whether this solution what we got is optimal or not, we use a condition. Cj minus Zj should be less than or equal to 0. Yes, the condition is satisfied. So all Cj minus Zj values are less than or equal to 0. Then the optimal solution is x1 is having solution of 8 and x2 is having solution of 2. Now let us go for objective function. The objective function is z is equal to 6 x1 plus 8 x2, where x1 is 8, x2 is 2. So substitute the values, we get z is equal to 64. The conclusion is the optimal objective function z value is rupees 64 profit. So this is a method to solve linear programming problem using simplex method.